to subtracting polynomials. So now that we've looked at collecting like terms, we've looked at that using our algebra tiles, so that graphical representation, and we looked at it using just the algebraic representations. Now we're going to look at those skills and combine them by adding and subtracting polynomials without drawing those visuals. So when we're adding polynomials, we can remove the brackets that are given to us that separate each of those polynomials. Then we're going to collect the like terms and simplify. So let's go through some examples. You'll notice that I've included some equal signs in my solutions. This sort of gives you a guideline of how many steps you should start with. The more you do this, the more efficient you might be able to be, and you could do some of these steps in your head or combine some of these steps. But by starting out, it's helpful to use these equal signs as our guide to show us how many steps we should have in our solution. So the first step would be to write this expression without using the brackets. So just 3x plus 1 plus 4x take away 2. The next part would be to look at collecting our like terms, so moving our like terms beside each other. And this could be one of those things where you want to look at highlighting or underlining your like terms. You could start with it might not let me do it because I've written here, but I could use my underlining. So I can underline my x's, so I have 3x, and underline my positive 4x, and then not underline my constants. So that could be a way to distinguish your like terms. So my next step would be to write those beside each other. So I'm collecting those like terms. So 3x plus 4x, and then my constants plus 1, take away 2. And then the last step in your solution would be to simplify your like terms. So 3 plus 4 gives me 7x, and 1 take away 2 gives me negative 1. Looking at our next example, I'm going to start by just rewriting this without any brackets. 5x squared plus 5x plus x squared, take away 7x. Now I want to collect my like terms. So 5x squared with my plus x squared, and then my x's, so plus 5x, take away 7x. Now I combine those like terms or simplify. 5 plus, remember this an imaginary 1 here, 5 plus 1 gives me 6x squared, and 5 take away 7 gives me negative 2x. Continuing on, I have my next set of examples. Example number 3, first step, just rewrite this without the brackets. Negative y squared, take away 5, plus 3y squared, take away 4. Combine or collect your like terms. So I have negative y squared. My other y squared is right here, plus 3y squared. And then my constants, negative 5 and negative 4. Simplifying my like terms, remember this is an imaginary 1 in front of there. So negative 1 plus 3 is 2y squared. And negative 5 take away 4 is negative 9. Moving on, example 4. Rewrite it without your brackets. 2y cubed minus 3y squared. Take away 5y squared. Take away 4y. So I'm going to combine or collect my like terms. I'm starting with the largest exponent. So I have a y cubed, and I only have one of these, so 2y cubed. Now I want to look at my y squareds. I have my negative 3y squared and my negative 5y squared. So I'm going to group those two together. or collect them together. And lastly, I have my just y, so negative 4y. So now I want to simplify or combine my like terms. I only have that one y cubed, so I have 2y cubed. Negative 3 take away 5 is negative 8y squared and negative 4y. Next one, 2x to the power 4 minus 5x squared plus 3 plus 7x to the power of 4, take away 8. So I'm going to collect my like terms. I'm starting with my largest exponent. I have my x to the power of 4. So I have 2x to the power of 4 plus 7x to the power of 4. Then the next one I have is an x squared. So I have negative 5x squared. I only have one term that has an x squared. And then my constants, plus 3 and negative 8. Last step, I'm combining my like terms or simplifying. These are both words that you might see and read when you're doing these questions. So I have 2 plus 7 gives me 9x to the power of 4, negative 5x squared. I only have one of those terms. And then plus 3 take away 8 is negative 5. Example 6. First step, rewrite this without your brackets. 5x squared plus 7x minus 7 plus 4x squared minus 8x plus 12. Collect your like terms. I'm going to start with my x squareds. So 5x squared. The next one is a 4x squared. Then I'm going to go with my x's. Plus 7x. I have a negative 8x. And then my constants, negative 7 and plus 12. Lastly, simplify or combine. 5 plus 4 is 9. So I have 9x squared. 7 take away 8 is negative 1x. You might see this written as a negative 1. Sometimes, and I'll just write it down here as well, you might see it as just negative x. So both of those would be okay. And then negative 7 plus 12 gives me positive 5. So if you write your expression with a negative 1x or a negative x, these mean exactly the same thing. So either of these final answers would be okay. Okay, so you may write your final answer as one of these. So now that we've looked at adding polynomials, let's take a look at subtracting polynomials. So this could be a little bit trickier. So this is where we need to think about those opposite expressions. So when we looked at it graphically, we looked at drawing the same shape but different shadings. So if it was a empty one, we shade it in. If it was a shaded one, we write it empty. So same shape, different operation or different sign. So we want to think about writing that the same way. So the opposite expression would be the same numbers or same letters and the opposite signs. So instead of a positive, I'm going to write negative x squared. Instead of a positive 4x, I'm writing negative 4x. And instead of positive 1, I'm writing negative 1. So same variables, same exponents, same coefficients, but opposite signs. Example B, instead of 4x squared, it becomes a negative 4x squared. Our negative 2x becomes a positive 2x. and our negative 3 becomes a positive 3. So same numbers, same variables, same exponents, but opposite signs. And last one, our negative 3x squared becomes a 3x, so positive. I don't need to write that positive sign out front. Negative 7x becomes a positive 7x. And our positive 2 becomes a negative 2. So it's important that you understand how to write opposite expressions so that when we are subtracting our polynomials, it's easier to write our solutions without brackets when we write them as opposites. So let's take that one step further. So when you see it in the question, you're going to see the expression inside of a bracket with that negative sign out front to show that you're subtracting. So when a negative value is in front of a bracket, it really means the opposite of what's inside of the bracket. So we're going to simplify each of the expressions by writing this as the opposite expression. So when we are subtracting the polynomial, we are actually rewriting this as the opposite expression. So this one would become 4x, negative 4x. So this is positive inside the bracket, so it becomes negative outside. And then 3 becomes a negative 3. Part B, our opposite of this, so it's a positive 2x inside of the bracket, so it becomes a negative 2x squared. Positive 4x becomes negative 4x, and negative 5 becomes positive 5. We're going to look at what that means when we look at distributive property and even multiplying polynomials a little bit later, but for now I want you to just think about as the opposite polynomials. And you'll notice this one's a positive, so just a little twist in here. So because it's a positive, we don't need to change our signs. So this one would just stay as our 5x and our negative 3. So now let's combine that by subtracting polynomials. So again, you'll notice that I have given you some equal signs as a sort of guide to help you know how many steps to include in your solution. So when we're subtracting polynomials, we want to move the brackets. But when we remove the brackets, we have to write our second polynomial as the opposite polynomial. And then we can collect our like terms and simplify. So the first bracket stays exactly the same. The first polynomial stays the same. So there's nothing you need to worry about changing for that. So the 5x plus 6 stays as a 5x plus 6. The subtraction sign here shows us that we now need to write the opposite polynomial. So the 2x becomes a negative 2x and the 4 becomes a negative 4. Now we collect our like terms. So I'm going to start with my x's. So I have 5x, take away 2x, and then my constants, plus 6, take away 4. Now I simplify or combine them. 5 take away 2 is 3x, and 6 take away 4 is 2. So let's go through another example. The first polynomial stays the same, x plus 5. The second polynomial, we're subtracting it, so we have to write the opposite polynomial. So the 3x becomes a negative 3x, and the negative 1 becomes a positive 1. So we're switching those signs. Now we collect our like terms, starting with our x's. I have x minus 3x, then our constants, plus 5, plus 1. Now we simplify. Remember, there's a 1 in front of this x. It's an imaginary one. We don't often write it, but you can if that's helpful for you. 1 take away 3 is negative 2x, and 5 plus 1 is 6. Next example. Our first polynomial, there's no sign out front, so it just stays the same, x plus 4. I'm subtracting the second polynomial, so I am changing the signs, so I'm writing the opposite polynomial. So my negative x becomes a positive x. Our negative 3 becomes a positive 3. Now I combine my like terms, my x and my positive x, and my constants, my 4 and my 3. Remember, these are 1's in front of these x's. 1 plus 1 gives me 2x. 4 plus 3 gives me 7. Example 4, first bracket stays exactly the same. So first polynomial, 2x plus 5. I'm subtracting, so now I have to write my opposite polynomial. 2x becomes a negative 2x. Negative 7 becomes a positive 7. Now I'm combining my like terms or collecting my like terms, starting with my x's. I have 2x, take away 2x, then my constants, plus 5, and then plus 7. 2x take away 2x, or 2 take away 2 is 0. So you could write this as 0x. Sometimes we don't write it at all. So once we've eliminated a variable or eliminated a term, then we can just take it away from our example or from our question. Then we have 5 plus 7, which is 12. So you might see it written as this when you're first starting out. Sometimes it's helpful to see it as 0x plus 12, or you may also see this written as 12. So this would be a preferred final answer. Your 12 I would like to see that, but if you write 0x plus 12 when you're first starting out, that's okay. And last two examples, example number 5. I'm writing my first polynomial just the way it is, 2y squared plus 3y minus 5. I'm subtracting my second polynomial, so I need to write the opposite polynomial. 3y squared becomes negative 3y squared, plus 3y becomes a negative 3y, and negative 4 becomes a plus 4. Now I want to collect my like terms. I'm going to start with my largest exponent, which is my y squared. So I have 2y squared. I have another one over here, so negative 3y squared. Then I'm going with my y's. I have my plus 3y and my negative 3y, and then my constants, negative 5 plus 4. Last step, combine those like terms or simplify. 2 take away 3 is negative 1y squared. 3 take away 3 is 0y. And negative 5 plus 4 gives me negative 1. So first starting out, you may write this answer as this. As you advance, you'll know that I can rewrite the negative 1y squared as negative y squared. I can eliminate this term altogether, so I just have negative y squared take away 1. And then last example, example 6, the first polynomial gets written exactly how it is, so negative 3n squared plus 2n. I'm subtracting my second polynomial, so I'm writing the opposite polynomial, so my 5 becomes a negative 5. My negative 4n becomes a positive 4n. And just to make life interesting, we've added another polynomial here that we're going to add. So because we're adding, we don't change this polynomial. So it stays as a positive 7 and a negative n squared. So you can add and subtract more than just 2 polynomials at a time. So we're going to start with our largest exponent. So we're starting with our n squared. So I have a negative 3n squared. And going along, I have one more right there. So I have a negative n squared. Then I'm going to look at my n's. I have my plus 2n. And then I have a plus 4n. And lastly, my constant. So I have a negative 5 and a plus 7. Last step, I want to combine or simplify. -3 take away, remember this is a 1. So -3 take away 1 is -4n squared. 2 plus 4 gives me 6n. And -5 plus 7 is plus 2. And that is how we use algebra, so without any visual representations, and the concept of like terms to subtract and add polynomials.